Hello everybody, my name is David Kinahan. I'm a lecturer in the School of Mechanical and Manufacturing Engineering, and welcome to today's webinar on the course, the Higher Diploma in Engineering, Analysis and Technologies. As you see, today's 27th of July, but it's 2021, not 2020, so apologies for that. So I'm going to take you through some information related to the course, and then we'll open up then to some questions if anybody has any. So I think the easiest way to handle the questions is if you put them into the chat box and then you can read them out, or alternatively, if you want to speak, I think that'll work as well. So just briefly, some background on Dublin City University. It's ranked as one of the top 2% of universities worldwide, and has recently been ranked as 19th in the world for graduate employment rate, which we think is exceptional. It's something we're very proud of, and it's something that we put a lot of focus on, the employability of our graduates, and that's reflected in things like our work placement program, Intra. We're considered one of the world's leading young universities, and we're the highest ranked young Irish university, so that's universities that are less than 50 years of old, and we are ranked in the top 100 universities globally for social and economic impact. The Higher Diploma is going to be based within the School of Mechanical and Manufacturing Engineering and within the School of Electronic Engineering. So the two schools combined offer degrees in electronic engineering, mechanical engineering, biomedical engineering, a new course, sustainability engineering, and we also offer a course on mechatronics. And the Higher Diploma is actually based upon the syllabus of the B.Eng in mechatronics engineering. That course has been running since 1998. So the Higher Diploma is effectively a subset of some of the modules that are delivered as part of the mechatronics degree. Mechatronics and the Higher Diploma are both very multidisciplinary courses or subjects. So they offer a kind of hybrid of mechanical and electronic engineering. And this is specifically focused and very, very useful for the emerging areas of interest in the workplace. So things like automation is one of the, and robotics are two of the critical focuses of our mechatronics degree. The course is continually renewed and updated to reflect technological advances in industry and R&D. And we also are convinced that we're offering a highly relevant course. So we think we're delivering students out into the workplace who have the knowledge and skills that are in really high demand. So specifically for the Engineering and Analysis Technology Higher Diploma, the reason we're offering the course is we've identified that the workplace has become increasingly automated, and a lot of engineering roles are very focused on solving analytical problems, and particularly at the interface of mechanical engineering, electronic engineering, and software and computer engineering. So what we're trying to do is offer you a kind of subset of skills that you have some of the training of a mechanical engineer, some of an electronic engineer, and some of a computer and software programmer. And that basic foundation then will allow you to move in any of the three directions that your employer may need you to move into. And specifically what we like to do is develop critical thinking and problem solving skills. What we find is a lot of the know-how that's required in, say, mechanical engineering, a lot of that is directly transferable across into electronic engineering, as long as you have a really strong foundation in the underlying mathematical principles and you know how to approach a problem in order to solve that particular problem. We specifically aim to deliver graduates for workplaces of the future by providing that strong background in mathematics and programming and a very strong background in that analytical problem solving. And what we want to do is, as I said, is aim to be platform independent. So we want to deliver the students transferable engineering skills. So like I said, something you learn in mechanical engineering related to fluid flow is directly, can be directly transferred across to work for DC and electronic engineering circuits, for example, or a problem-solving skill or a mathematical skill that you learn related to electronic engineering may be something that you can apply if you are given a programming challenge in industry. So the program overview, first of all, we're planning, COVID permitting, to run 2 semesters this year. So semester 1 will be 10 weeks, slightly compressed. And for the first time, we're actually doing our exams before the Christmas break rather than after the Christmas break. So it'll be a 10-week semester. There'll be a week break, and then there'll be a week of exams, and then the Christmas break. Then for semester 2, you'll return on the 10th of January. You'll have a 12-week semester up to the 2nd of April, and then your exam week will be end of April, early May. As part of the module, what you'll effectively be doing is you'll be taking 6 modules in the first semester and 6 modules in the second semester for a total of 60 credits. So it's a 1-year full-time qualification. And then we'll talk a little bit now about each of the individual subjects that you'll study. So we kind of divide the subjects into 3 major streams. So the first stream is the mathematics and problem solving stream. So the first thing you will take is, I've actually skipped numerical problem solving for a second, engineering maths 1 and engineering maths 2. So these are first year engineering mathematics modules. They build on maths that you might have covered as part of your honours leaving cert, for example, or you may have covered it in your other qualifications that you've taken since then. And the key learning is to introduce students to the central role of mathematics in engineering and reinforce their problem solving skills. And you'll study topics such as vectors and coordinate systems, engineering software, calculus, linear mathematical functions, functional approximations, and complex numbers, and then even more advanced calculus and engineering maths too. You'll also take part in the first year mathematics module, numerical problem solving for engineers. This is a little bit more, as the topic says, it's a little bit more focused on problem solving as opposed to pure mathematics. And you'll cover topics such as plotting, curve fitting, and again, vectors, calculations, calculus, and complex numbers. You'll also then take the 3rd year module, data analytics for engineers, and this gives you some underlying skills and abilities in areas such as data analytics, statistics, and probabilities. This is a particularly good module because it also kind of takes into some of the emerging topics to do with, say, machine learning and things like that to a slight degree. Data analytics is a really, really critical emerging area of interest, how to analyze large data sets and perform complex statistical analysis on them is something that's really, really key to the emerging workplaces of the future. The next stream then is what we call our computing and software stream. And you'll take part in the first year module, which is software development for engineers. So you'll learn about basic and advanced programming architectures, the correct style and modularization of code. You'll primarily learn this through the C programming language, and you learn basic concepts and syntax, and then how to work with data types such as arrays, strings, and booleans. You'll learn how to implement functions and how to work with, say, pointers and lists as well. You'll then take part in the operating systems module. So this is a little bit more focused on developing code for real-time optimization. So it'll be how to use the Unix and Linux operating systems, how to work on memory management, current processes, and inter-process communications. The third of our computing and software stream is embedded systems. So this is basic and advanced applications of embedded systems. So for those who may not be familiar with embedded systems, this is things like microcontrollers and FPGA, field programmable gate arrays, and things like that. So these are the real industry focused, specialized microcontrollers that may be used in industry. And this is actually something that's become really, really important as well. If you hear people talk about, say, Internet of Things as an emerging area of interest, a lot of Internet of Things are based upon it's an embedded system that is connecting to the internet is what your actual Internet of Thing actually is. So your fridge that's maybe connected to the internet that can be monitored from home, or your home heating system that's running on an embedded system. The final part of the stream then is more of the core engineering topics, and we kind of just call this the energy systems and entrepreneurship stream. So the first thing you will be studying is energy. So that is energy and introduction to thermodynamics. So this is a little bit more on the mechanical engineering side, and it teaches you about how heat engines work. So you learn the fundamentals of heat transfer, work, mass transfer, the laws of thermodynamics, how refrigeration cycles work, and then a little bit about environmental aspects of, say, global warming, the ethics of fossil fuels, renewable energy, and nuclear energy sources are covered by this as well. From a design perspective then, design and computer-aided design and development is basically learning to draw things with 3D CAD software. So that's primarily SolidWorks. So you learn solid modeling in CAD, you learn dimensioning, how to extract out 2D drawing, how to do some animation in CAD, and also how to use CAD for solid physics models as well. So a little bit of computational modeling is tagged on to the end of this. Again, a very important thing to learn. If you're working in industry as an engineer and you need a component made, you need to be able to design it, check that it's working properly, and then provide the excellent 2D drawings to the workshop so the technician can actually make the component. Similarly, if you want to use 3D printing in the future, you need to be able to design your system in 3D CAD software. The next topic then is engineering mechanics and statics. So this basically introduces you to the fundamentals of mechanics. So things like the balance of systems, how to find the static equilibrium of a system, how to draw a free body diagram, how to calculate the forces in a truss member, how to calculate the center of mass of an object, a little bit about buoyancy and stability of floating objects. Then this links in then to thermodynamics by looking at, say, work, equilibrium, dry friction, and a little bit on potential energy. From the system side, we have a module on pneumatics and control. So this basically ties in a little bit to our previous embedded systems. It's basically you're learning about pneumatics and control systems, and particularly you'll be learning a little bit about PLC controllers, so programmable logic controllers. And they're a controller type that's widely used in industry for programming workshop machinery and specialized instruments. So you learn about things like, from the pneumatic side, you learn about compressors and clearance volumes. You learn about pneumatic circuit components and hydraulic fluids. And then you will learn about how to apply, say, ladder logic to programming PLCs. The final module then to talk about is our new enterprise development project. So you take part of the first year of this. This is a really entrepreneurship focused module that's delivered jointly with the business school to a lot of our engineers. And you will be taking this with some of our third year mechatronic engineering students. And effectively, it's talking about how you can translate your engineering knowledge into industry, and particularly into an entrepreneurship and startup environment. So there's a key difference between an inventor and an innovator. An inventor is somebody who comes up with a new idea. An innovator is somebody who takes that idea, whether they invented it or took it from somebody else, and actually manages to apply it in industry. So a classic example of that would be somebody like Elon Musk. He may not have invented the lithium-ion battery, but he has innovated by using it in the Tesla car. Similarly, he didn't invent the rocket, but he innovated by advancing it and making them making them reusable with SpaceX. So it's that innovation is what we try to imbue in our students through the development module. So in this, you learn to do things like identify the stakeholders who might be interested in a new venture, conduct a commercial case feasibility study on a new concept or invention, develop a business plan, and perform a market analysis. So I was involved in examining some of these students last year with the business school, and it was really incredible. The students went out working as groups, identified some problems to solve, and then conducted a really detailed analysis of potential new technologies and new businesses. And I actually, more than one of the ideas that were put forward, you could actually see a viable potential startup coming out of it. So it's a really, really impressive module. So there are the modules. Just a little bit of an overview of online delivery and laboratory attendance. Each of our modules has about 24 hours of total lectures per semester, so about 2 hours per week. And then there will be scheduled labs and tutorials as well. They'll be scheduled on your timetable for every week, maybe 2 hours of labs and 1 or 2 hours of tutorials each week. Although typically those labs and tutorials will only run 2 or 3 times per semester, maybe 4 or 5 times per semester, but certainly not every week. We're aiming again for a hybrid delivery mode. So last year we did video lectures using Zoom, and these were recorded and put up online. We're hoping that our lectures will be completely in person this year, but we're planning that the lectures will also be made available online. So it may be last year's material if the lectures this year have been delivered in a lecture hall that don't have live recording capability. You will also, however, have in-person laboratories. Last year, these were scheduled so that you had to attend basically the minimum amount, but again, depending on COVID, there may be more extensive laboratories this year. So I think last year, our higher diploma students only needed to attend campus 3 times in the first semester to attend laboratories. Their laboratories were effectively scheduled for 1 full day on 3 weeks. However, like I said, this year, we're hoping that it will be a little bit more back to normal. So the laboratories may be a little bit more spread out and a little bit more involved. In terms of online tools, the online delivery will be through the virtual learning environment, which is our Loop system. It's also called Moodle if you want to look it up. You'll have remote DCU library access. It's not written down here, but we also have a system called App Connect, which were set up last year, and it's working quite well and will be expanded this year. And App Connect is effectively a cloud-based access to engineering software. So for example, if you have a laptop that's a little bit old, rather than downloading SolidWorks 3D CAD to run on your laptop, you're able to log into App Connect over a fast internet connection, and that remotely logs you into a server within DCU, and you're able to draw or use SolidWorks on that actual on the server. And it means then that you can actually run very high powered and resource intensive software from an older laptop if that's what you need to do. You'll get direct support from the module coordinators and also from me. I'll be in continuous contact with you through the semester as the program chair. And as I said, laboratory and timetabling. The plan last time was that each year would attend once a week. Because the higher diploma is based on modules from 1, 2, and 3rd years, then you might have to attend multiple days per week. But again, that's still something that we're trying to lock down based on timetabling and also based on emerging COVID numbers. If there is a surge in September, October, we may end up reverting to what we did last year, which means that you may be only on campus once or twice in the semester. So a little bit of the other information. There is the potential for you to progress from the higher diploma. So if you are a graduate from a level 8 degree with a 2-2, and you also have a higher H4 in Leaving Certificate Mathematics, there is a potential for you to be interviewed by our MEng program chair. So if you wanted to stay for an additional year to convert your diploma, actually you wouldn't convert your diploma, you'd still have your diploma, but you could study for an additional year, which would be basically at a master's level and do a project over the summer. And that would get you an MEng, which is accredited by Engineers Ireland. So you'd be recognised and eligible to become a chartered engineer. The higher diploma is not a qualification that's accredited by Engineers Ireland as of yet. Another piece of information just for now is that a lot of our students from last year did flag that the course is very intense. It's really has to be addressed on a full-time basis. It is a very high workload, quite a lot of project work. A lot of the project work is a reflection of COVID, that a lot of our courses have transitioned from end of semester exams to a little bit more intense continuous assessment. What I would say is that there's some very good mathematical resources. So there's a recommended website called mathtutor.ac.uk, and there's the DCU Maths Learning Centre. And while you're considering joining the higher diploma, I would highly recommend that you have a look at those two links, particularly MathTutor. It acts as a bridge from 2nd level to 3rd level and can help you understand the level of maths we're expecting our students to have as they come into the course. Finally then, you'll find more details about the application on the Springboard website. Our deadline is the 24th of August, 2021. It's just been extended out from the 1st of August. So you have a little bit more time to consider before you apply. If you have any administrative queries, contact Anya, she's on the call, or if you have academic queries, please feel free to drop me an email as well. Just a reminder that the entry requirements are, we'd like you to have either a level 8 with a minimum of a H2-2 in a non-engineering related discipline, or you can have a level 6 or level 7 in an engineering discipline with a minimum of 5 years relevant industrial experience. And again, those entry requirements are pretty much subject to interview, and the main thing we'd be interested in is the level of maths that you may have in the Leaving Cert, or that you may have studied since finishing the Leaving Cert. And again, that's just a reflection of how very mathematical this course is. That sets you up for the modern workplace, that those analytical problem solving skills that you learn are absolutely key. But it also makes it a challenging course. So just please keep that in mind, that it is a very, very mathematical course. Finally then, These fees are from last year, but I don't think they've changed significantly. If you're in employment, the keys are 564 euro. And if you are not in employment, the courses was free last year. And again, just a reminder as well that this is a very intense course with a lot of project work. So please remember that it should be taken on a full-time basis. And I think we can stop there and take any questions that anybody might have.